Hi, in this video, I'm going to show you two methods of how you implement a value object, and I'm going to try to give you some metrics and why do I think one method is better than the other one. And the idea of making this video was actually from one of my posts in the LinkedIn, where I documented how I implement a value object like the company name and why I have chosen that approach. One of the commented was, why don't have a base class for all the value objects to inherit from? I'm going to try to make right now a comparison with metrics, why I think one method is preferred by the other one, and give you my thoughts and let you decide. So first, there are two methods of implementing a value object. I'm going to give a reference to the Milan has a great article of two methods. One of them is using C# records. This one requires to have a new compiler like the C# 9. And the one it's using base class, like the value object base class, and have all the value objects inherit from. And the idea of having a base class for value object, it came from the books where you learn domain-driven design, and I really think it's a great way to implement an abstraction, a technical concern for the value object, and it's good for learning. However, I have never used such an object and such an implementation in practice, and I do software development for about 15 years. I'm working with DDD for around 10 years. So I'm going to show you why I don't use this approach and why I find a couple of disadvantages. So first, let's understand what the value object base class is doing. So it's nothing more than a references. So it implements a class where it implements iEquitable. It implements an equality with the same instance, and also it overriding the object in a get hash code. And what's so special is that has these get atomic values where return all the properties which are interested to be considered in the equality and actually in the get hash code. Let's have a look how many times these get atomic values it's used for. So it's used to values are equal, it's used to aggregate the hash code, it's used also in the equality compare. So we use multiple times just for identifying the equality and get hash code. So basically that's the only function here, because two different instances with the same values has to be equal, and has to be equal from the comparison point of view and also from the hash code. So a proper implementation would be this one, like having address value object, we're inheriting from the value object, we're having a couple of properties, and then we are yielding all of them. So this is the example, the first one, and the second one, it's this address record where we do have the record. Now the first disadvantage is that you are fixing a technical implementation by using inheritance. The address value object, it is a business concern. And the value object base class, it's actually bringing you some technical concerns. The link between these two, the coupling, is given by here. Now, my problem is that you are facing a business concern with a technical concern, like inheriting here. So I'm not a fan of inheritance. But what if you do have another address, let's say a special address where you do have GPS coordinates? Well, you're going to tell me that's actually pretty simple. So let's say we have a special address, we're inheriting from address value object, and all I have to do is just to return the base values and return the other values. So in this way, you can add the existing functionality and add two extra ones. Now, because you can fix doesn't mean you have to do it. So I'm generally not a fan of fixing a business concern with the technical. So that's the first disadvantage. The second one is that you will unable to define the value object as a struct. So struct cannot inherit from anything else. Given this address value object, you are only restricted to reference type. So you can never have actually the address value object as a struct because you cannot inherit from a class. Now, if you're looking to my previous video, I do recommend value objects to be implemented as a struct, and actually that's the way how I do the default implementation. So this is a limitation which you cannot get over. There is no possibility neither in C# or in .NET CLI. So this is a limitation which you're gonna get stuck with it. Now, let's talk about some metrics. So what is happening to the value object? The third one, well, this one you are doing an allocation of IEnumerable. So every time when you're creating yield return, you're allocating an enumerator where you return all this value. This enumerator, I don't think it's our big problem, but it's still an extra allocation which you're doing. Now, compared to the record, there is no need of extra allocation because the equality comparers are implemented by the C#. So these are using the default equality comparer and are using street. All the members field are implemented with using default equality comparer. So there is no need of such a thing. So if you compare one way with the other one, you're gonna lose some performance benefits. I agree that it will enter in the micro optimization, but it's still been an extra allocation here. Now the fourth issue and the fourth concern is that it's gonna be happening the boxing. So aside of the extra enumerator, here to the reference type, you will not have any boxing because you're gonna have all the members are reference type. But if you're gonna go to this one where we are specially implementing using GPS, float are value types. So when you cast a value type to a reference type because you have to return an object, then you're doing a boxing. So this is an extra allocation on the heap besides to IEnumerator. The IEnumerator is allocated every time you're going to call get atomic values. Now, if you're going to add this as a key in a hash set, so let's say I'm going to do this and I'm going to define a hash set here, new hash set of this, you can do that. And the hash set will use by default get hash code. So it will use an allocator to compute the get hash code. So this will be the first allocation. And then when there is a conflict, depending on the hash implementation, we're going to do an extra allocation for values are equal. So we're going to do one allocation minimum of the IEnumerator and maximum 2. But how about the boxing? The boxing is directly linked to the number of properties that are value objects. So here I do have a special, let's check out to the first one. So address value, it's inheriting for value objects, and I do have special address, which actually I'm going to comment here. I'm going to put a comment, okay? And I do have another class where I'm using the same class like the address value, but I'm just replacing zip code. I'm using an integer, and here I'm using integer as well. So I'm having two classes with the same name because I want to do a comparison. So that's the fourth problem and the fourth performance issue. Now the sixth one, and I find one of the actually more important, is that by default, you're going to use the default equality comparer. Now this is also true in the record class, but check out what is happening. So let's say I want to make street comparison to be in case sensitive. In that case, I'm going to return to say 2 to lowercase invariant, and I'm going to use this string for comparison, for equality, and also for get hash code. So this will be an extra allocation besides the extra allocation of the enumerator and possibly boxing of all the members. So this is actually another performance penalty. I agree this enters in the micro optimization, but I'm going to make a benchmark to show you exact numbers. And in case you still want to not use the default equality compare, then all I have to do is not use neither record, neither the class, but to implement your own iEquality. Actually, in the previous video, I'll show you a typical implementation of ValueObject where I am case insensitive for given two company names. I want to be equal if the characters are insensitive. So check out the previous video. That's a production ready code. When I filmed the video, I also did some benchmarks, but we're a bit different, and I think these ones are more easy to follow. So I have three classes. I do have the address record where I do have all the fields here, and I'm using the record. The code actually is very small because I'm using the built-in features of the C# compiler. And I do have the address value where I'm inheriting from the value object. Here I do have the same fields like in the C# record, but I'm implementing get atomic values, and I yield all the fields here as in the enumerator. The third class, I'm inheriting from address value object because I'm adding two more extra fields. I do have here two of the fields are value types, so I'm expecting the boxing effect. And in the get atomic values, I'm using the base get enumerator, and I'm also yielding the value types, but I'm also returning a new enumerator. So here I do expect to have two enumerator allocations and the boxing effect here. And the benchmark, it's looking something like that. I am comparing equals for the record class, for the value object class, and for the value object with boxing. So I'm comparing equals, and I do the same for the get hash code. I'm using actually some categories because I want to illustrate the difference between these two. So get hash code, as you can see, I'm doing the same thing. Now I do have actually the results, and they are looking like here. The C# record, it is the fastest. The equals, it takes 2 something nanoseconds. Here, the C# record, it's using in the get hash code, it's 40 nanoseconds. Actually, you can read the numbers. I'm gonna just focus here on the ratio. So this one is the fastest, the C# record, and the slowest, it is up to 70 times slower. Now, the fastest among slowest, it is this one, 2.5 times. So value object class get hash code, this one, it is the fastest among the slowest. This is actually one of the things which you're going to notice. You will hardly write any code faster than the compiler itself. Maybe you can find a different implementation for the value objects, but in my reference, actually, I obtained 2.5 slowest. Actually, to the allocation, you can have a look here. So value object, where I'm using equals, I'm allocating 80 bytes. These are the equivalent for the enumerator. And here I'm expecting slightly double than this. So 80 multiplied by 2, it's 180. And the difference, so 100 bytes, I expect to be the boxing effect. So that's the reason here I do have a slightly more difference, because I'm doing 2 allocations. The base class allocation like this one, and I'm allocating an extra more. So I hope these explications were clear. Now, actually, I'm going to update the benchmark continuously. So I'm looking forward some comments from you. If you see any problem with the benchmark or any code, just drop me a comment, and I'm going to put a link in the description, by the way, for the benchmark. This will be already published on my GitHub account. Now, I want to wrap up a couple of conclusions, and I would do recommend to use C# value class C# records to implement a value object every time when you do it. You can see you will hardly write faster code than the compiler itself, of course, if it matches the scenarios. So there are also some limitations for the record class. And by the way, for the limitation, I do have a video, and I'm gonna put again a comment in the description where I implement myself the record, where I'm implementing myself the value objects, because I cannot use record due to its limitations. And to understand better, have a look here in the description to the video. So my recommendation is to use C# record every time when it makes sense. If you do have already some code which is using the base classes, so the value object base class, I do recommend first to write some unit tests and then slightly replace them with C# records, because you will find some situations where, for instance, here I am not gonna yield the zip code for the comparison. Maybe this one makes sense for that value object, so don't compare the zip code as well. So that could be a situation in your case, and if you're gonna replace the C# records, then the compiler will consider this comparison as well, so it will change the behavior. So write some tests first for the value object that you want to replace, find a couple of corner cases, and then replace with records. So in this case, you're going to obtain speed and less allocations. But this will enter in the micro optimization. I totally agree with this. Now I hope my explications were clear and you will be able to understand why I have never used the base class value objects. I think you can actually constrain the code by using some architecture and fitness functions that will have the same behavior, but to be as a governance in the code than the value object has. So I have never used these value objects because I saw the drawbacks, but also maybe you find a better implementation for the value objects. So that's actually the case. Drop me a comment with anything which you see problematic with the code. And until the next time, see you soon. Bye.